right, we have to solve some problems, some log equations in part of this assignment, and so I thought I would do 25 because I figured it would scare everybody a little bit. What you have to do here is, again, if you're having trouble with this label, this equation is going to be, if you think about what your base is e, the exponent that's on this side is the minus 1, and then what's it equal to? The number is x minus 4. But if that didn't come to you that easily, let's do it a longer way for those of you who are struggling, okay? I could rewrite Ln as log base e, and then I have this x minus 4, and I have this minus 1, negative 1, okay? So if we label this, this becomes log a, b equals c, and then I say, okay, I'm going to rewrite it in exponential form so I can solve it. So the a was e, the c is negative 1, and then the b was x minus 4, okay? So that's how I got what I have over here to the right in black, okay? So that's how I could have gotten it if I didn't see how to do it, you know, the quick way. All right, let's look at this for a minute. We've got e to the minus 1 is x minus 4. I need to solve for x, and I got this e in there, and I don't really like it, right? So what I could do is I could ln both sides. If I ln both sides, or natural log both sides, that would get rid of it, okay? So that's one way to get rid of it. Actually, I don't have to do that now that I think about it. You know what? It's not like I've got an exponent caught up somewhere, so actually that's overkill. You know what? If I want to solve for x, all I got to do is add 4 to each side. Let me just do that. That's actually probably better, okay? So if I want to get x by itself, I just add 4 to both sides, and I get x equal e to the minus 1 plus 4, and what e to the minus 1 is just 1 over e plus 4, and so the book is going to write this as 4 plus e to the minus 1. Any of these would be fine. This is what the book writes, 4 plus e to the minus 1. That's equivalent to those other two statements also. So, yeah, we actually didn't have to ln that. And you know what made me stop doing that was when I looked at it, I thought, well, yeah, I'll get my minus 1 over here, but then I'll have a ln x minus 4 over there, and I'd really rather not have any ln's, natural logs at all. I'd really just have x is equal to a number. So sometimes you do something and you kind of make it more complicated and you back off. That's what just happened in my brain right there, in case you're wondering. But if you want to solve for x, you know, you could just move the terms around, because e is a number, just like pi would be a number. So there's no point in having an ln in your solution if you don't have to. So you got 27. You've got ln x squared is equal to 9. Okay, so if I want to, now here I've got a log, I'd really like to get rid of it, right? So let me do this. Let me take and make, I'm going to exponentiate each side, which means I'm going to put ln, I'm going to take each side and make it an exponent, and e is the base. Why did I do that? Well, because these would cancel out, right? I'm trying to get my x squared by itself, and the reason I did that is I don't know how to get the x squared by itself any other way. It's in a ln, and I guess I could have rewritten it. That might have been another way to do it, but this would get rid of it really quickly. So if I make this an exponent with a base of e, I need to make that with an exponent with a base of e. As long as we do the same thing to both sides, we're good, okay? So what does this leave me? Since these two things kind of cancel out, I get x squared is equal to e to the 9th. So if I square root both sides to get x by itself, remember, as soon as I square root, I need to put a plus or minus on it. I get plus or minus e to the 9th power. Oh, sorry, the square root of e to the 9th. Okay, so let's deal with that. There's got to be a better way to look at it than that. Well, here's what, I'm just checking to see if the book did anything different. If you get x equal plus or minus the square root of e to the 9th, that's kind of a mixture of an exponent here and a radical. Do you remember that if you got a radical, a square root, you can write that as a half, an exponent of a half? So that's what the book's doing when you look at their answer. It's plus or minus e to the 9/2 power. These two statements are equivalent, and this is the answer. They don't try to get e's outside and leave an e in. They just put it as e to the 9/2 power. Again, it's kind of hard sometimes to know what to do. Sometimes your answer might be the right answer. It just may be written in a different form. This would be preferable not to mix. The reason we would want to go ahead and do this is we don't want to mix a radical and an exponent unless we want to go ahead and look for pairs of e squareds in there or something. So this is just an easy way to take care of that problem. Okay, if we look at 31, I'm purposefully skipping some that if you see how to do 31, you should be able to go back and do number 29, for example. So I'm purposefully skipping some. Just remember they're in the same section. A lot of times they're going to have the same sort of work. All right, I've got an x as an exponent. It's an exponent on a base of e. How am I going to get rid of that e so I can get to that x and start solving? Well, I could ln both sides. I could say ln e to the 2x because ln and e are opposites of each other, and I could ln 25. Okay, these two kind of cancel each other out, and I end up with 2x is equal to ln 25. Okay, now, some books would be fine with that, okay, and they would just divide by 2 and just say x is a half. They divide both sides by 2. They'd say x is a half ln 25, okay. What this book does, it takes it a step further. It says, okay, since we can get rid of this a half, because just think about it, where could it have come from? It could have been an exponent on the 25. So they go ahead and do this. They go x is ln 25 to the 1/2. But that means, if you look at this expression right here now, that's the square root of 25, and we know what the square root of 25 is. It is 5. So you can kind of keep simplifying, and this is really just a matter of how far do you want to simplify, and this would be your best answer right here. Probably on your test it's going to be multiple choice. You're going to be trying to match up your solution to a multiple choice answer, so you'll kind of go, okay, can I make my answer look like one of these? If for instance, let's say you'd gotten this far and you didn't, and that wasn't an answer choice, but you see ln 5, you're going to say, okay, I must need to be able to simplify that to something else. Okay, so at 35 they say solve and leave your answers in terms of e or natural logarithms. We hardly ever write a decimal answer on these things unless it's an exact decimal answer. Okay, so you try to solve for x. It's inside of a radical. There's a couple of things you could do here. I'm going to go ahead and just do what maybe a lot of you might think to do. I can think of 2 major ways to get started here, but let me do this. If you've got a square root of something and you want to get rid of it, couldn't you just square both sides? That would be one way to take care of this, okay? So that would be the square root of something squared is just the thing in the radical. That would be e to the 3x is equal to 9. Now, if I want to get rid of the e here, because the x is still an exponent, isn't it? Here, where's my x? It's right here. How am I going to get it out of this e here? Well, if you think about it, what you can do is ln both sides, natural log both sides. So I'm going to take the e to the 3x and I'm going to ln it, and I'm going to take the 9 and I'm going to ln it. Well, these two would cancel each other out, and I'd have 3x, or they would undo each other because they're inverses, like a square and a square root are inverses. I'd have 3x is equal to ln 9. And if I want to get x by itself, I could divide both sides by 3. Now, if you think about it, you'd have x equal ln 9 over 3, but isn't that the same thing as a third times the ln of 9, right? Okay, my answer is not agreeing with the book answer, but I don't see what I've done wrong. So there's a possibility I'm wrong, there's a possibility the book answer's wrong. I can't see their steps worked out. I don't have a solution manual, so I'm just going to kind of keep going. If you are watching the video and you see where I've made a mistake, let me know, okay? Because I just don't see what's wrong here. It seems like this is right. Okay, so we ln'd both sides, and we got 3x is equal to ln 9, okay? So then I divided by 3, that's a third ln 9. So what we could do now, if you think about it, this could be an exponent here. So we could say that's ln 9 to the 1/3 power, which is the same thing as ln of the cube root of 9. The book has the answer ln 9. I don't see how they're getting that unless I'm looking, I miscopied. Okay, so here, let me scratch that out because I copied the problem down wrong. I looked at another problem when I wrote this one down and mixed 2 problems together. So let me do the real 35. This is not right because I miscopied. There was not supposed to be a 3 there. That's why at the end I had an extra a third. I couldn't figure out where was the book getting their answer. Let's do the real 35. The real 35 is square root of e to the x is equal to 3. So I could square both sides just like I did before, and I would get e to the x is equal to 9. And then to get the x off of that e, I could ln both sides, just like I did before. It's just I had a wrong number in there. And these would undo each other, and I would have x equal ln 9. That's how the book got their answer. I miscopied.